decimal to binary. In the world of computer science, understanding the hexadecimal system is a superpower. Hexadecimal or hex is a base 16 number system that uses 16 distinct symbols, that is 0 to 9 and A to F, which is indirectly 10 to 15. So A to F is indirectly 10 to 15. The computer understanding the binary language only, it is very important to obtain the binary equivalence of any hexadecimal number. Question 1. Give 3 reasons why the digital computers uses the binary system only. It is true, it is not only the binary system that they use it, because there are certain aspects when it comes to computers where the hexadecimal is equally used. I will take an example just like with colors when it comes to web programming. But well, let's answer the question. One, it is because the binary system consists of 0 and 1 only, which are the perfect states for logic circuits, which are the fundamental building blocks of digital system. Two, binary devices are simple and easy to build. And as third reason, the binary system is unambiguous, making it immune to noise, to signals. Now, what do we mean by unambiguous? Because in binary, we know what 0 represents and we know what 1 represents when it comes to communication and when it comes to other aspects of computer science. Subroutine construction. A file, program.c is provided in the candidate folder. Your main task is to complete the program by using the commands in the program and the questions provided to you. Question 1. Include the necessary libraries as indicated in the program and run. So let us open the program.c that was provided to us. So this is what we have. This is the program.c, as you can see. Let me close this. So this is the program.c that we have. That's supposed to complete based on a different comment and the question provided to us. So first of all, if I run this, we realize that there is an error that says what? Line 10. It says unknown type bool. And we know that for us to use the bool keyword, we need a boolean library, as it's even indicated here. So the first thing they say, include a library for input output functions, and we know that it is hashtag. Sorry, some problem with the keyboard. So I have my hashtag include standard input output dot h, then include a library for string functions. So I have my hashtag include uh, string dot h, and finally hashtag include boolean function stdbool dot h. So that is what we have. If I run it back, 0 errors, and the program runs correctly. Conversion from hexadecimal system to binary system. AF6 is valid, its equivalence is. So that's what we have. Now we proceed. This is simply what we have. Yes. Now the next question says that the subroutine the subroutine verify present in the code is used to determine if a particular hexadecimal number is valid or not. The variable value is initialized to AF6. Let us look at it. Yes, this is the value AF6, which is a valid number as shown when the program is run. Let us see it again. When we run, it says AF6 is a valid hexadecimal number. Its equivalence is, but it does not give us the equivalence. Good. So now, what do we have? Question 2 says, initialize value to an invalid number, run and save a screenshot of the output as invalid rex. So we need to initialize value to an invalid hexadecimal number, and we know that for a number to be invalid in a hexadecimal system, the different letters should not be in between A and F. So I can just remove this F and A and I put GK, which are out. So if I run this, what does this say? GK is an invalid number in the hexadecimal system. Correct. So that's what we were supposed to do. You do your prints, your screenshot, and you save in your candidate folder. Okay, we proceed. Now, the mean equivalent of hexadecimal digit is determined using the 8421 method. Description. Every hexadecimal digit has 4 digits in binary. This digit corresponds to the coefficients of 8, 4, 2, and 1 when the hexadecimal digit is expressed in terms of those 4 digits. For example, when we have 7, 7 is expressed as what? 0 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1, which gives us 7. So, as you saw in the video when we were doing binary conversion, I think this same method was explained. The link to the video on how to convert from octal to binary and binary to hexadecimal system is provided in the description of this video. What we are saying here is that for us to obtain the binary equivalent of a hexadecimal number, it is just from the coefficient of 8, 4, 2, and 1. For octal, it is the coefficient of 4, 2, and 1. So now, for 7, we cannot express 7 in terms of 8. That's why the coefficient is 0. We move to the next digit now, 4. 4 can be extracted from 7. That's why you have 1 here. And when you extract 4 from 7, you are left with 3. The 3 remaining, 2 can be extracted. That's why you have coefficient 1. And 1 is left, which is the one we have here. A, which is 10. When we extract 8 from 10, which is possible, that's why we have this 1 here, because if you cannot extract, that's when your coefficient becomes 0. But if it is possible, your coefficient is 1. So since 8 can be extracted from 10, that's why you have this 1 here. What is left? 2. We cannot obtain 4 from 2. We cannot extract 4 from 2, that's why the coefficient is 0. And now 2 can be extracted from 2, that's why the coefficient is 1. And when you extract 2 from 2, you are left with 0. That's why, since 1 can't be extracted from 0, that we have this 0 here, making A to be 1, 0, 1, 0. Now, express the numbers below as multiples of 8, 4, 2, and 1. Hence, give their binary equivalence. So, I will just do it here for you guys to see. Then I will delete after. So, when I have 9, can I extract 8 from 9? Yes. So, I have 1 into 8. And I'm left with 1 because 9 minus 8 is 1. Can I extract 4 from 1? No. So this is what I have. Can I extract 2 from 1? No. So this is what we have. And then the last one, 1 can be extracted from 1, making 9 base 16 in binary to be 1, 0, 0, 1. When you come to D, which is 13, can we extract 8? Yes. So I have this one. We are left with, when you extract 8 from 13, you are left with 5. In 5, can you extract 4? Yes, coefficient is 1. When you extract 4 from 5, you are left with 1. 2 cannot be extracted, so this is what we have. And then the final 1, which can be extracted, making 13 to be 1101. Is 2. That's what we have for question 3. Okay, we proceed. The algorithm to compute this equivalent is given below. So this is the algorithm that is given to us, the algorithm to obtain the binary equivalence of a hexadecimal number. Convert the algorithm above to a programming language subroutine under the command defining it in the program. So when we come hex to bin, let us see, subroutine that gives the binary equivalent of a hexadecimal number. So we are here. So what do we have? It's a procedure. So I have void hex to bin. It takes n as an integer, a parameter, sorry. Now, what do we have? Inside the subroutine, we have variables. We have comparator and we have digit, which are all integers. So I have comparator, I have digit, which are all integers. Remember that C follows a syntax in contrast to pseudocode. So this is what we have. Now, from there, they say set comparator to 8 and digit to 4. So comparator is equals to 8, digit is equals to 4. Now, while n is different from 0 or digit is different from 0, what do we do? So while n is different, that is not 0, or remember that or is given as two straight lines, that is or, and then what again, digit is different from 0. What should we do? Now we have first thing, if n is greater than or equal to comparator, so if n is greater than or equal to comparator, what should we do? You see that inside the if we have two statements, so we are obliged to use the braces. Then I should print one, so print f 1. Then I set n to be equals to n minus comparator. That's what we have. Else I should print 0. That's what we have. The else is having one statement, so if you want, you can say remove this braces, no problem. Now, after we are done with the if else, what do? We should decrement digit, meaning that what? Digit reduces. Now, what do we have? We set comparator to comparator divided by 2. So comparator is equal to comparator divided by 2. That's what we have, and we end the procedure. And remember, anytime you are writing a subroutine, always make sure you hunt to identify if there's a problem within the subroutine. So as it hunts, it shows that we don't have any problem within the subroutine. That is what we have. Question 5. Write a subroutine equivalence that takes a character and returns its integer equivalent, that is A to return B to return 10, B to return 11, and so on. The subroutine should return -1 for characters different from A to F and B. Make use of the switch statement, because the switch statement is what is most appropriate here, because we are returning values based on other values. So what do we have here? I'm done with this subroutine. Subroutine used to give integer equivalents of the characters A to F. Good. So this is where we are. And we say that what? It's a subroutine. The name is equivalence. Yes. It takes in a character, that's our parameter, and it returns what? An integer. And since this subroutine returns an integer, it means that it is a function. And a function is characterized by one of the characteristics of a function is its return type. And in this case, it is integer, because it returns the integer equivalent. The name is equivalence, and it takes a character. It takes a character. So I'm going to say character code. Good. So now what do we have? Once I have the code, what am I to do with it? I simply switch within that code. In case it is A, I should return 10, and I break, because that's the subroutine. That is syntax for switch statements. Remember, same thing for B, C, D, E, F. Oh, we have very fast when it comes to copy and pasting. You need to be used to it, and then you simply modify. So I have C, which is 12. I have D, which is 13. A, B, C, D, E, which is 14. Then I have F, which is 15. And in case it is different from that one, which keyword are we using for such? When it comes to the case that does not, when it comes to a value which is not present in our case, what do we have? It is the default keyword. What am I going to have? I'm going to return, the question says you return -1. Then we break. So that is what we have. We run and see if there is no problem with that. Good, no errors. Now, as seen in the program, Value storing the hex number is a string. Let us see value. Yeah, you see that value is a string. And remember that here they use the other syntax, that is a declared string as a new data type of 7 characters. Int we need integer equivalence of the characters. Remember, 5 is different from 5, yes, because 5 within single quote is a character, and the 5 without a quote is an integer. And we need to know how to convert, how to obtain the integer equivalent of such number. That is why they gave us this particular hint. Question 6 says, write a subroutine conversion which takes as parameter a string s, iterate throughout the string, and give the binary equivalence of each digit in the string using the hex to bin subroutine. Means the following should be noted. If the characters is 0 to 9, the integer equivalent should be obtained using the formula integer is equals to character minus 0. Then we use the hex to bin subroutine. And if the character is in between A to F, the integer equivalent should be obtained using equivalence. That is what we have. So let us proceed, dear students. Where is that subroutine? Subroutine that converts the hex number to equivalent binary number. So this is where we are. So here it does not return a value because it is parameter throughout the string and give the binary equivalent. It does not return. So we have void conversion. It takes a string as parameter, so string s. Then we loop throughout the parameter. And we know that if you are looping, we need a counter. So for I equals to 0, I less than the length, the length of the string length, I increments. What do we do? So first of all, we need to know whether it is a character or it is an integer. And here they are saying that what? Here they gave a hint. They said the characters A to F have integer value 17 to 22, while characters 0 to 9 have integer value 0 to 9. Check the valid subroutine for better comprehension. When we come to the valid subroutine, where is it? Valid subroutine. This is verify x to b equivalence conversion. I don't think it was written. Oh, yeah, I'm sure they meant but verify. So this is the number we have. If number is less than 0, and so on and so forth, result is equal to false, return this. So this is what they are using. They are using to know whether it is a number or it is or it is a character. So for that, what do we do? So we are going to need this. So we are going to use this because this is what determines if it is an integer. So we come if here our string is s. So if s is less than 0 or greater than or equals to 0, or it is being less than 9, less than or equals to 9, it should be and. Meaning that what? This means we are starting from 0 right up to 9. That's what it stipulates. And if that is the case, it means that what? It is a numeric number. And in that case, we need to convert it to an integer before calling the hex to bin. So as such, what are we going to have? Hex to bin. Let me explain it back. This stipulates that what the character we are having is an integer, that it's a character, but it is that of a number, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And in that case, as it is stipulated here, it should be what? Character minus 0 before we use the hex to bin. So inside hex to bin as parameter, I'm going to have s at position I minus the character 0. Else. The else means that it is one of those number A, B, C, D, E, or F. But now we are not going to use a condition to verify that one because we already have a subroutine verify that checks whether it is a valid hexadecimal number, because if it is not valid, we will never arrive at this level. So if it is a character, what are we going to have? Hex to bin. And as parameter, what are we going to have? We first of all convert that character using the equivalence subroutine. And then we pass in s at position I. That is what we have. So that's what we have for our for loop. And I think we are okay with that. Before the hex to bin, I will like to, anyway, let us proceed. Now, question 7 says, complete the main program to prompt the user to enter a hexadecimal value. So we are here, enter a line of code that will enable the user to enter a hexadecimal number that will be stored in the variable value. So what do I have? Scanf %s comma ampersand value. And then here I need to remove this initialization. That is what we have. Good. Then system CLS means that what if after you enter the value, it's going to clear the system. Then we verify. If verify it is true, it is a valid hexadecimal number. And then they said question 8 says call the conversion subroutine with the right parameter to display the result. So at this level, you see it says equivalence is, I need to call that subroutine. So let me just add this. Then I will call the subroutine conversion. It takes as parameter a string, and that string is a value. That is what we have. Then they say run the program with the value BEAC and screenshot. Let us run first of all. 0 error, which is good. Conversion from hexadecimal system to binary system. The hexadecimal system has a digit 0 to 9 and A to F. NB, the characters A to F must be in capital letters. Hexadecimal number, if I enter BEAC, it says BEAC is a valid hexadecimal number. Its equivalence is, now what I wanted to add is after the conversion, that is after every hex to bin, I want to put a printf of some spaces 1, 2, 3. Good. So if I run it back now and I enter BEAC, good. BEAC is a valid hexadecimal number and it gives the different equivalents, as you can see. So I hope you enjoyed the program. I hope all the different aspects were tested, that is conversion of an algorithm to programming language, understanding the problem, working with strings, for loops, the switch statement, because most of you will think that switch statement is a construct that is rare when it comes to evaluation, but we need to master all these different aspects. And I hope you also learn on the conversion from character to integer equivalent, as it was already explained in one of our tips. Do not forget to like, subscribe, and to share for our community to grow. And see you in the next video where we shall be decrypting exercise number 5. Thank you and see you in the next video.